All right, so you are choosing a university class. That was our previous example that we're looking at, and we're going to expand onto that example and take a look at three different ways of measuring what we might consider to be normal. Okay? So there are several different data analysis tools that we can use to analyze data, sets of data like the ones that we had previous with our university grades. And the first three that we're going to look at are called measures of central tendency. They're all measuring the same thing, well, not really the same thing, but they're all measuring normal. Okay, what is normal? And there's different ways to measure normal. The first one is something called mean. Okay, so first one that we're going to look at, let's undo that, is the mean. Okay, and this is what we would consider to be the arithmetic average, the calculated average. Okay, and this is something that we often use in many things, whether it is in our marks, whether it is in uh, what people like. Okay, we often consider it to be the arithmetic average, which we calculate. Okay, it's a calculated arithmetic average. It's used to find the value that is exactly in the middle of all data points. And that should be say points, not point. It's used to find normal when looking at a large set of data. Okay, so that it's looking at what is normal. Now we have two different ways of measuring it. Okay, number one is what's something called X bar, and so you can see a little bar there on top of the X. Okay, that's if we have some of the data. Okay, so if we have some of the data, we're going to be using something called X bar. If we have all the data, we're going to use mu. Okay, and we'll use those kind of throughout the course of this unit here. Okay, you'll often see this little U, which is actually, it's a Greek letter called mu. Okay, it's mu. We're going to be using that as we're going to kind of say that we probably have most of the data or all of the data. Okay? A couple other letters, and so sorry. The formula for finding the average of a set of data, it looks like this. So let me just see if I can. I might have to do that after. Oh, there we go. Okay. X bar is equal to, and now we're going to use a couple of different things here. If we can put them in, there we go. Sum of X over that one's not going to work. Should be a summation sign. Okay, we might have to do something a little bit different here. Okay, summation of X over M. Okay, and I'm going to draw that little summation sign in there, as it looks like I don't have that tool. So summation sign is just this little sign right there. It's like an E. It's the Greek letter sigma, which means sum of. So this is the sum of all of our data points. X represents each piece of data. We're going to have a whole bunch. In the case that we're going to look at soon, we have 20 data points. Okay, so we're going to look at the mean. We're going to look at the sum of all the data points, and then we divide it by how many data points we have. Okay, and so if we do this with our if we do this with mu as well, okay, it'll look a little bit different. We're going to take our mu is equal to the summation of X over N. And again, I'm going to put in summation here with a drawing tool. So the summation, there we go, summation of X. So all of our data points. So we add all of our data points together, and then we divide by how many we have. Okay, so you've probably looked at this. If you want to take a look at the average heights of certain people, we add all the heights together, divide by the number of people we have, and that's going to give us our average. Okay, and we'll go through an example of that a little bit later. You've probably done examples of that in the past, and we're going to take a look at that when it comes to those marks a little bit later. The next one that we're going to take a look at is something called the median. Okay, the median is the piece of data that is physically in the middle of a sequential list. Okay, it's right in the middle. It's that middle value. Okay? It doesn't matter the average. This picks out exactly the middle piece, which means that we're actually going to be kind of getting rid of some extreme scores. So if there's an even number of data points, then we find the average of the middle two. And this is best used with a very large group of data. And this is used effectively when there are extreme scores present, and you may want to downplay the impact of the average. Okay, and we're going to take a look at this, and this is actually really comes into play with Professor Rosenthal's data, and we'll see kind of what that means. It gets rid of the extreme scores. It gets rid of the ones who are maybe outliers that shouldn't be considered with the normal, and that's when we talk about data. Okay, but that's really important. Let's take a look at a quick little example of that. Okay, so this example is dealing with two kinds of phones. So Haley is deciding on a new phone and wants to determine which one's going to last longer. So she collected some data on how long 9 iPhone and Samsung phones lasted in years. Okay, so how many years they're going to last. And so she's determining which one's going to last longer. So here we have 9 pieces of data, and we want to figure out which one is best, or which one has the higher average life expectancy, so to speak. To do that with median, what we need to do is we need to organize all of these in order from smallest to biggest. So we want to organize them from smallest to biggest, not just pick out the middle one. We want to organize them from smallest to biggest. So I'm going to put in, I'm going to write them all out in smallest to biggest. Okay, so we're going to start with iPhone here on the top. Okay, the smallest one there is 0.2, then we have 1.1, then we have 1.3, then we have 1.7, then we have 2.2, 2.3, 2.4, 2.9, 3.0. Okay, so there's our 9 iPhones, and this is listed from smallest to biggest. We're going to do the same thing here with our Samsungs. 1.5, 1.6, 1.8, 2.0, 2.1, 2.3, 2.4, 2.6, 2.8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. All right, so we want to try to figure out which one's better, which one has the higher average. Okay, and the way we're going to take a look at that today is in the median, or at least in this case. So if we look at the middle one, there are 9 data points. We're looking at the 5th one. So 1, 2, 3, 4, 5. This is the 5th one right here. Okay, so the median age of an iPhone is 2.2. That's that middle value. Okay, and you'll notice that it doesn't matter what these ones are on the left, doesn't matter what the ones are on the right, it just matters what that middle one is. Okay, so it's just looking at the middle one. For a Samsung, it's 2.1. That's our middle data point. Okay, so you'll notice here the iPhone actually has a higher middle data point than the Samsung. Whereas if we were to actually calculate the means of these here, okay, they would potentially be very different. Okay, like if you look at this, we have that 0.2. That's an anomaly. That means that phone lasted like not even, well, just over 2 months. Okay, that's not a long time. Normally they last a lot longer. So that's probably an anomaly right there. So we want to try to get rid of that. And using median, it gets rid of that. Okay, and so that's a way to kind of take a look at there. If we do the data, and so I have a little bit of data kind of, I'm just going to show it to you here. If we find the average for, there we go. So the average for an iPhone is 1.9 years. And the average for a Samsung is actually 2.1 years. And quickly put in, I'm trying to keep my notation as best as possible here. It goes 2.1 years. Okay, so if you look at the averages, or the mean for an iPhone is 1.9, the mean for a Samsung is 2.1, which are pretty close, but that means that the Samsung will probably last longer, okay, on average, right? That's our average. But the median shows that the iPhone actually has a bit of a higher average in this case, okay, because some of this 0.2 really brings down that X bar, that mean. Okay, it really brings down our mean, but our median really shows it to be a little bit better. The final one that we're going to take a look at is mode. This is our final measure of central tendency. The mode is the most frequently occurring piece of data in a data set. So this is the one that occurs most often. It's often used when the exact of existing data needs to be the average. Okay, sorry, that is, yeah. So it doesn't make sense to round it off. It's going to make sense when there is a lot of data, and maybe when we don't necessarily have numbers involved. Okay, so if we don't necessarily have numbers involved, we just have like data pieces, and we want to figure out which one's the most common. Okay, most common is going to be the mode. It's the most frequently occurring. So here's an example that we have. A survey is done to find the best fast food burger. Okay, and this is actually one that I did with grade 11s in the past. Okay, and they chose. You'll notice here I've written them out in with alphabet. Okay, we have AW is for A&W, BK is for Burger King, DQ Dairy Queen, McD McDonald's, and WEN is for Wendy's. Now this is before Wendy's and Burger King came to Steinbach, so that might have a little bit of a play on it as well. But you'll notice here, if we count up how many there are of each, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 people chose A&W, whereas only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people chose McDonald's. Based on this here, if we were to take just the middle one, okay, so if we were to take the middle one out of all of these, and now they've been organized in shape or from in alphabet, okay, that one right there is the middle one. Does that mean that DQ is the most common or the most popular? No, it's probably the least popular or pretty close to least popular. Okay, that's definitely not. But A&W is the most popular. It's the most common. Or sorry, A&W. Yeah, I think I said A&W, right? A&W is the most common as it is the mode of the data set. Okay, it's the mode of the data set. We can't take the mean because there's no numbers. There's nothing to, number it up. Okay, so that means that we have to look at the mode. We have to look at the most common one. Okay, in this case here, it's A&W.